we're going to write the fifth Taylor polynomial, and that really does mean fifth degree, and you could put the word degree in there, but you don't have to. And it's for that function, it's centered there, and we know the general formula, so let's grab a marker and let's do this. So if I wanted the fifth degree Taylor polynomial, then, well, there's a general formula that will follow, and I'm going to put in some of the unnecessary stuff just so we can get the hang of the pattern. So I need to know what f of pi over 2 is. This is the 0th derivative, it's the actual function itself, and it's divided by 0 factorial, and that would be at x minus pi over 2 to the 0, and I know that was very unnecessary because we're dividing by 1, and this is 1, I get that, but it helps us understand the pattern. And then we're going to add that to the first derivative at pi over 2 over 1 factorial, which of course is 1, and then x minus pi over 2 to the 1. Probably didn't leave myself enough room to write this. And then third, f double prime pi over 2 over 2 factorial, x minus pi over 2 squared. Yeah, I can fit one more term here. Erase that. And we have f triple prime of pi over 2, pi over 4, over 3 factorial, x minus pi over 2 cubed, and we need 2 more terms. This is the fifth degree, which means we have 6 terms. So we're going to have f fourth derivative, pi over 2, and that would be, I almost put 6 factorial, that'd be 4 factorial. I was looking at 3 factorial and noticed it was 6. So 4 factorial, and then x minus pi over 2 to the 4th. And then our last term, and I know this seems very long, but you're going to notice with this one, and with cosine as well, whenever you do one of those, a lot of stuff really starts to cancel out often, not always, depending on where you are on the unit circle. 5 factorial, and then x minus pi over 2 to the 5th. Okay, so we are going to write that. So we need to figure out some certain pieces to it, and one of those pieces will be, well, what f of pi over 2 is, and what f prime of pi over 2 is, and what f double prime of pi over 2 is, and all these things are going to go in there. So let's just go ahead and start working through that. So here's f of x. I'm just going to write it, just to have a good clean pattern going on here. So sine of 2x, cool. F prime, we're going to write f prime. We're going to write the second derivative. We're going to find the third derivative. If at any point you get tired of putting apostrophes and you want to put the number up there in parentheses, you can. So the fourth derivative and the fifth derivative. Okay, here goes. The derivative of sine is cosine. We need a 2 there. The derivative of cosine is negative sine. Put a 4 there. The derivative of negative sine is negative cosine. The derivative of negative cosine is positive sine. And the derivative of positive sine is positive cosine. Lots of chain rule going on in there, and we just didn't really have to deal with it that much. So as we do this, we're going to start figuring out what happens as we plug in pi over 2 into each of those. So let's switch colors one more time. And we're going to find out what f of pi over 2 is. We're going to find out what f prime of pi over 2 is. In case you're wondering what's really happening here, we're trying to find all the components we need just to fill this in. Now, we didn't do that on the very first example because we were kind of gaining an understanding of the formula. But now that we understand the formula, we understand where the factorials come from and why they're necessary, we don't need to go through that anymore. We just start plugging stuff in. So this one is the same idea, but a different process because we already understand, hopefully, where the formula comes from. 2 f4, fourth derivative of pi over 2, and there we go. Okay, well, here goes. When we plug a pi over 2 here, we have 2 times pi over 2. 2 times pi over 2 is pi. Sine of pi, well, sine is the y value, and the y value at pi is 0. So this is 0. All right, cool, lucky us. And actually, that's going to continue to happen. I hope we notice the pattern, so let's just go ahead and keep going. So we're going to plug in a pi over 2. I'm already to the second derivative because I'm about to show you that all the even ones are 0, right? So we plug in pi over 2 here. 2 times pi over 2 gives me pi. Sine of pi, 0. Same. So even though this seems like a very long problem, it gets really short really fast because every other term is going to drop out completely. However, we can plug pi over 2 in here. When we plug in pi over 2 here, we're going to have cosine of pi. Cosine of pi is negative 1. See, negative 1 comma 0. So negative 1 times 2, so negative 2 right there. We are now going to plug pi over 2 in right here. Cosine of pi, again, negative 1 times 8. And we do the same thing here, negative 1 times 32, so negative 32. And that's what we have. So as we do this, all we have to do now is just fill the numbers in, and we'll be done. It'll really be that easy, and we'll reduce it as we go, I think. I would wait till the end to reduce it and make an extra step, but it's not worth your time. So this first term is gone, because this is 0. So again, I'm skipping a step, because we know what's about to happen. This whole thing right here is 0, and this one is 0, and this one is 0. So this term, and this term, for what we're dealing with, they're gone. So if you wanted to, you could just, that one's gone, and that one's gone. There we go. So we're only left with the odd number derivatives. Okay, so let's plug those in. We have negative 2 over 1 factorial, which is nothing special, that's just 1. X minus pi over 2. I guess 1 is special in its own little way, right? And then we will figure out what that is, which we already did. It was 8. And we have 8 over 3 factorial. I'm going to reduce that. Leaving that as 8 over 6 is perfectly acceptable, but I just don't like it. So 4/3, a little bit of middle school math as we continue our calculus. And this is to the third. And then we have the fifth derivative, pi over 2, which was negative 32. So negative 32 over 5 factorial, which is 120. We'll reduce that in just a second. I'm stalling because I don't know what it is off the top of my head. 32 over 120, let's see, 4 goes into the top, 8 times, 4 goes into the bottom, 30 times, that still divides, so divide that by 2, 4 over 15, is that what I got? I didn't even reduce it on my paper. So we're going to go with that. 4 over 15, and I want to double check that one more time. So bear with me as I'm double checking my work. If we divided the top by 8, we'd get 4. If we divide 8 into 120, we'd get 15. Yep, it's right. There we go, we found it. So if you wanted to graph it, you would notice that around the graph of y equals, ooh, wow, missed. That was terrible. Sine 2x, it's about right here. And the first degree Taylor polynomial would be a tangent line, and then it starts to kind of hug the line a little bit closer and follows the contour the higher the degree gets.